Hello everyone on the ReactiveConf 2018. It's great to be here with you. So my name is Jarda Machaň and I'm the developer evangelist in GoodData. And I also love my wife, and she's here today watching me for the very first time on stage, so I shouldn't screw this up. Thank you for the opportunity to speak at such a great event. And today I'm going to talk about our latest data visualization called GoodData.UI SDK contribution to this analytical field. Let me just really quickly and briefly introduce GoodData. We have started the company more than 10 years ago in Prague and also Brno, and now we are headquartered in San Francisco. At the beginning, there was this nice whiteboard and a brilliant idea of data analytics in cloud. Maybe it sounds a bit ordinary now in 2018, like watching Tupac's hologram rapping on the stage of Madison Square Garden. But back then in 2007, it was $1 million idea. So there were those 5 guys in love with advanced algebra, data, and new technologies who kick it off. Currently, we are an end-to-end data analytics platform, which enables you to load any kind of data, process it, transform it, and finally analyze and visualize it. That means that there must be some dashboards at the end of the day, right? But believe it or not, there was no dashboard in the initial phase of the product in 2009. But customers wanted it, obviously. So this is the very first dashboard in GoodData. As you can see, no option of drilling or filtering, but an option to embed it to your solution, which I would say is a crucial feature in the data analytics field. Let's move to these days. We are really strong in so-called business to business model. You can imagine it as, for example, our biggest customer, Zendesk, is providing analytics for more than 28,000 of their customers, for example, Uber or Google, and they are using GoodData for this. So it means they need to use GoodData front end in many different solutions. What are the options to use GoodData out there in your solution, in your context? You can embed it using iframe. You can also white label it using our API with the JSON configuration file. You can also dig even deeper and use our low-level JavaScript API, but it doesn't stand much for the context of the word simple. And this is the time for GoodData.UI SDK to come to the stage, because it allows you to programmatically shape and customize our visualization front end using those simple React components. So from now, you are not limited to use just the embedding, using sometimes those heavyweight iframes, and you could use ready-made React components in your solution. And because you are developers, so we don't want to limit you using just our components. So there we go, using the so-called execute component, which allows you to wrap any lines of your custom code or the visualization you need to use, no matter if it is D3 high chart or whatever visualization package on NPM. This all together means that GoodData.UI SDK allows you to code the whole application, the whole solution, including your visual brand identity or taking the, for example, approach to the responsiveness you take. So please have a look at our developer site where you can find not just the documentation, but also the library of our React components, which also comes together with the source code. So maybe some of you would like to play a bit around locally, so fork it, and it would be absolutely great if you could share any thoughts you will have, any ideas, any criticism to it, so we can follow your thoughts as a community. And that was all for me for today. Thank you a lot for your attention and for the opportunity to speak at the Reactive 2018. Bye, see you.
Hello, everybody. My name is Vojta, and I work in a great company called productboard. You can also find me on Twitter as Vojta_Přikryl. Today, I'd like to talk about drag and drop and building interactive UIs. Drag and drop. Everybody loves it. Cats love it. Humans love it. Everybody understands it. You know, even my grandpa knows what to do. Oops. We at productboard, we especially love drag and drop. And when we were thinking about implementing next features, we went to NPM and boom, there was a lot of it. So we tried some libraries like React DND. It was probably the first good DND library in React. It has great docs, it's hackable, but we couldn't use it. It didn't allow us to create delightful experience we always aim for. So we tried React Beautiful DND, and yeah, it's beautiful. You know, if you are building something like Trello board, you can do it in a matter of minutes with this tool, but again, we couldn't use it. It was for us to opinionate it, and once we wanted to extend the functionality in the library, there was like no way to do it. We're playing around with D3, data-driven documents. It's very powerful technology, but guess what? We couldn't use it. Now, we just didn't feel comfortable introducing whole new technology into our dev stack. Now, we are React guys, and we want to build things on top of React. So what are actually our needs? This is roadmap, one part of productboard. And what do we want here? Now, we want to drag cards. We want to drag whole columns. And at this point, you can argue with me, OK, so why didn't you use the React Beautiful DND library? That was exactly the use case, right? But not really. There's more of it. You know, we can turn on custom visualizations of the cards and look how beautiful animated it is. You know, we can hide things that it moves. You can turn on different view and scroll the board and look at the titles in the blue bars, how perfectly aligned they are at the edge of the viewport. So yeah, you can also collapse things and etc. We really believe that this helps our customers with using our product. When they have instant feedback on their work, it's easier for them to understand what's going on. And also, I think it's much more fun to use playful animated UI. So what is the trick? How did we achieve such beautiful animations even in quite complex boards? And ta-da, absolute positions. Let me explain. Here, on the right-hand side, you can see the DOM. If div represents one card on the board that's on the left. And as you can see, they are all absolutely positioned with Translate 3D. So when you are dragging, and the items switch, just set new 3D, X and Y coordinate, and it's just automatically animated with transition property from CSS, and you have it like for free, easy. There's more of it. Here, you can see that we are scrolling the board, and some of the divs starting to disappear. Why? Why is that? The cards are not in the viewport anymore, so there's no need to render them. And this is like really easy, great performance optimization. And once you have all the X and Y coordinates of each card calculated, it's just so easy to determine what to render and what to not. At this point, I'm glad to announce that we are open sourcing the library we created. You can find it at github.com/productboard/tbd/dbdnd. Quite a silly name, right? Well, we are in an early stage, but there are some examples already, a code, you can check it out. And yeah, any ideas, concerns, your experience with drag and drop? Just tell me, like, what do you think about it, if it makes sense or not. Let's talk, I'll be around, so approach me, say hi, and let's talk about it. Thank you very much.
All right, doesn't look like we have any questions. Is there anything else you'd like to add?
Well, not really, just if you are interested, check the open source.
Fantastic. Let's give him a round of applause. Thank you very much.
I'm here today to present you the FirstPack. FirstPack is a module bundler. You've probably heard of other module bundlers, right? Yeah, this is JavaScript conference, so probably you all know Webpack or Parcel. And this is the competitor, actually. So I'm Alexey Golovko. I'm the lead developer of this thing, and you can find me on Twitter and on a GitHub. So why another module bundler, actually? As a JavaScript developers, we face a lot of problems day by day. One of those is building times, right? So we picked just two random numbers, 1 second and 100 milliseconds, and decided to ask ourselves if we could do better. Could we get the sub-second bundling time, like on a cold build? And apparently, we are able to do it. So here you can see the benchmarking table comparing FirstPack, Webpack, and the Parcel, and the 3 rows in it. And the first row is an initial build. This is when you just installed your application and executed the bundler, and the bundler doesn't know anything about your application, but only the configuration you have given him. The persistent cache mode is the subsequent run, which means that there might be some artifacts from your previous build, and you can reuse those in the next build. And the watch mode is something you are very familiar with. This is when you're running dev server or just watching the file system, changing one file, and the bundle rebuilds. So to prove the table above, I actually recorded a little demo. So you can see that the first build in this demo takes 0.8 seconds, then the persistent cache, and at the top frame, I'm changing the code. And I just picked 2 random libraries, UI component libraries for React, which typically are quite big. So you can see that bundle size is about 5 megabytes, which is quite big, and this is not showing zipped or minified, so this is bundle as is. And then I subsequently added Gromit library to it, which actually duplicates the size of the bundle, as you can see during the next action. So what are the features of the FirstPack? So first of all, it's a fast bundler. That's the primary goal, and this is been said in the title. The second one, we are trying to respect the existing ecosystem, and we don't want developers to redo everything. So we are compatible with the Webpack loaders. We didn't try all of them, but the basic ones like CSS, LESS, SAS, whatever you name it, those are working. It also includes the basic transpilers required to run the code in evergreen browsers. So specifically, we are transpiling the spread and rest operators, removing flow typing, supporting class decorators and properties, as well as we are converting your JSX into the React-compatible JSX. Also, it includes the basic development server, but without the hot module reloading yet. It uses the flow parser behind the scenes, and it's written in ReasonML and compiled to a binary executables. With that being said, there are also the limitations you would expect it. There are no Windows support right now, but we are actively working on it. There is only the development mode, so you cannot build your bundle for production with the FirstPack yet. Simple page reloading by the dev server. It depends on a watchman for watching the file system. And the configuration is in a command line only style right now. And here is an example of the configuration. Don't be scared. This configuration is for real application we've been working on. And it actually includes most of the create React app goodness. So thank you all for listening me. Join our Discord channel, file an issue on a GitHub, install, try it yourself. Let us know what you're thinking of. Thank you so much. Oh, there are questions.
Ooh, we got a few questions for you.
I would not expect that. Sorry, guys.
First one, is tree shaking supported?
It was supported before, but then we've done a big refactoring, and it will be supported within a few weeks. So we are working on it right now.
OK, our next question. What about watch mode? I think it's a bit more important than initial build.
It exists. It's baked by Watchman, which is a Facebook utility. It works on Linux, Mac, and Windows, so it's supported. Let me know if it doesn't work for you.
Right, our next question. Why not contribute back to Webpack? Are there any core differences from Webpack that forced you to create another bundle?
That's a hard question. I think we can do better by applying binary builds, first of all, by applying their better parsing capabilities, because we are protected with the static typing, and our AST is strongly typed in. So it's way easier to develop the bundler based on such tools. So that would be my question, but
All right, our last question. Does it support TypeScript?
It does via the TS loader.
Looks like we might have time for one more. That was a quick answer. Is it complicated to replace Webpack with FastPack? How about projects with very customized configurations?
It depends. Some projects might be easy to be powered by the FastPack. Others might be more difficult. It depends project by project. Talk to me after this. I'll probably make an advice.
All right. Thank you very much, Alexei.
Who uses Redux? OK. So this is an opinionated talk. So feel free to cheer if you see something you like, or boo if you see something you don't like. My name is Adam Klein. I'm a developer, consultant, and trainer, and I'm the CEO of 500 Tech. In 500 Tech, we've started using Redux when it was just starting, and we built dozens of projects using Redux, and we learned a lot from each one. So the original talk was supposed to be sharing common mistakes, but instead I'm going to give you just a taste of our tools and best practices that work for us. So for handling immutable data, we use Lodash FP. Woo! No one uses Lodash FP. So it's the functional programming version of Lodash. It has a rich API, and if you're already using Lodash, then the methods will be familiar. And the code is very concise, much more than using plain ES6. So to make sure that the state never gets mutated, we use Redux freeze, which it's a library that deep freezes your state after every action, which means that if someone tries to mutate the state or by accident, then they will get an exception. We use it only in development, which means we don't get any performance penalties in production. And a great advantage about this approach is that we're using plain objects, which means that it's very easy to serialize and integrate with other tools. And that's the reason we don't use immutable JS. Yay! One clap. So our reducers are pretty simple. Sorry, no time for jokes. It's a lightning talk. We use handle actions from Redux actions, which allows us to avoid switch cases. And it also works great with TypeScript because it allows us to use a specific action type inside the handler. We use selectors for encapsulating access to the store. And we always keep them separate from the reducers. And that is because a selector might access data from several locations in the store, so we want to decouple them from reducers. We basically have two types of selectors. If we just need simple access to the store, we use plain functions. And only if we need some kind of computed value like filters, aggregated values, transformations, then we use the reselect library that caches the value of the selector. The way we handle side effects, async flows, stuff like that, is that we actually write middlewares, like an API middleware that handles all API requests in a generic way. We don't use any of these, even though I know they're very popular. And that's because we think they are either overcomplicated or force the developer to make, break the architecture or give them too much power in the wrong places. So finally, let's talk about state design. Let's take an example of a list of users that come from the server, and the user can select them using checkboxes. So we will store the raw data from the server on the state, and we will not change it. And notice that we're using a dictionary where the keys are the user IDs. And the UI state we will keep completely separate. So in this case, for each user ID, whether it is selected or not in the UI. What does this give us? It means that if we reload the data from the server, we can just override whatever's in the store and not worry about losing the user selection. And also, if we need to do things like save and restore the UI state from local storage, then it's much easier when it's separate. Sometimes we need to show some kind of loading indication, and we have a dedicated reducer and a set of actions just for the network state. And basically, we save the number of pending requests per request type. And request type is just a string label. And when that number is 0, we know that nothing is loading, and we can hide the spinners, etc. And keeping it isolated in a single reducer allows us to reuse the logic, and we don't have to re-implement it for every reducer that handles API requests. Sometimes we use higher order reducers, but we try to avoid them because we feel they make your code complex and hard to debug and prone to errors like name clashing of keys. Finally, I want to recommend two books if you want to get deep into Redux, the complete Redux book and thinking in Redux. You can get both of them online. So this was just a taste. If you want to hear more or tell me I'm wrong, catch me around the conference. Thank you.
Woo, we got some questions. Ready to go. Do you have public repo for your middlewares?
So we have a repo for boilerplate of our projects, which has a middleware, Redux, and a lot of other cool stuff. We will release it publicly, so probably just follow me or my company, and we'll let you know.
Right, another popular question. What do you think about IMA instead of I-FP?
Yeah, so IMA is a library for handling immutable data, in case you didn't know. Actually, we started using Lodash-FP before IMA was out. We like it, but I think if we would consider switching to something else, it would be IMA.
All right. Any specific reason why going with I-FP instead of things like Ramda?
Yeah, so Ramda is another library for handling functional programming. Yeah, and we find the API more complex and not intuitive. Like in Lodash, you have a function called set, and in Ramda, it's something like a sock path, something like that. So, and also, we know the API of Lodash, and it's enough for most use cases.
All right, probably time for one more. How about static type checking? Looks like, let's say, Flow won't play nice with I-FP.
Yeah, so it's true that when you use functional programming, static types is it's less effective, which is probably a good reason maybe to look at things like IMA. But you can still use it. There are advanced features in TypeScript that you can use. Yeah, I guess trade-offs, you know.
All right, that's all we have time for with the questions. I can see there are a few more, so find Adam in the break. All right, thank you guys.